So hey guys, this is Deepanshu Mehta, and today we are going to talk about my deep learning project, which is Smart Lock. And this project is based on person identification using machine learning libraries like NumPy, dlib, etc. The hardware we are using in my project is Raspberry Pi and a PiCam. So my deep learning project is totally based on the documentation and the marvelous work that has been done by Adam Galgay. I must be very thankful to him for such a nice documentation. But here in my project, I have actually do some manipulation, like some changes in my code. So there are some libraries change, and definitely this cost me for the accuracy. So yes, this is my online platform which I am using to generate alerts for opening and closing the door. Let me show you. This is UV dots, and this is generate free alerts for me, around 5,000 alerts. So this is the dashboard where I can see all the activity performed in like last 6 months. These are the devices connected to this online platform, and events like how many notification I need to generate for opening and closing the door. So like here it is phone number of my friend, so it is generating a notification for it. Okay, so going back to PPT. So these are the important components which I'm using in my project here: the Raspberry Pi, the IoT board, the Pi cam. This is the official Raspberry Pi camera which I'm using to as a to record the person face, and online dashboard to generate the alerts and to keeping a record that who is there at the door, and Wi-Fi, which is actually internet connection, a mechanical lock obviously. Now the smart lock system using Raspberry Pi. So why I'm using Raspberry Pi here? This board has a good processing power. It has a clock speed of 1.4 gigahertz, and it is a 32-bit quad-core ARM Cortex CPU. So it means that I can use my machine learning libraries here easily. Machine learning libraries like TensorFlow or NumPy, dlib, OpenCV. These are like run flawless on Raspberry Pi. So again, OpenCV stands for Open Source Computer Vision Library. This is a very important open source computer vision library used for the machine learning purposes, and this is the library which I am using to capture the face and to use the mathematical computation on this. So this is like a very efficient and adaptive method which can actually adapt itself according to the environment. So again, this is the screenshot of the documentation which I am using here. I will put the link of this documentation in the description, so there from you can access the documentation. This is me actually. So as you can see, the Raspberry Pi is recognizing me. Also there you can see that a name in a box, a green color in green letters, there is my name here. So I am been identified properly. So progress till now. So till now we actually have done all the software and hardware part. Now we are only done with some mechanical part like just with the lock. Okay, so the all the libraries, all the environment has been created successfully, compiled successfully, tested successfully. So we need like 1 or 2 days to complete this project. And the problems, or should I say the challenges, which I have been faced in last few weeks, are: the first one is the PyCam is not easily configured with the Raspberry Pi. Second is to assemble a physical lock to generate a sustainable lock which actually can prevent theft is like hard for a computer science engineer obviously, and to generate a client server which is so basically I'm using this client server because I want to like establish a machine to machine communication here machine to machine a Raspberry Pi, because like if one Raspberry Pi know that okay this lock has been open, so it means that owner of the house is now inside, so other locks must be open automatically. So drawback, the most, or should I say the biggest drawback of this model or this project is that the I'm not actually calculating the eigenvalue of the phase. Okay, so eigenvalues, what are those eigenvalues? As you know that the iPhone lock uses the eigenvalues. Okay, that's why it is so much accurate in identifying a person's face. My model is not much accurate, it because it just find a pattern, and according to that pattern it will show you the values, or it will show you the result, not actually calculating some eigenvalues here. Okay, so it means you can just show a pic of some guy which actually in the database, and it the lock will open for you. Thank you guys, my presentation over here. Now we will quickly move to the demo part. So let's see a live demo for facial recognition using Raspberry Pi. So here I started the VNC. Let's log into my Raspberry Pi. Wait. So this is a Raspberry Pi here. Let me change the setting, you can't see it properly. Okay, so now it's ready. Okay, let me first turn on the my virtual environment. This is the command. Work on is for to on activate my virtual environment, and DL, which I name give to my virtual environment. So it shows me that we are now in virtual environment here. So let me first, okay, this is my folder, this folder where I have all the files. Now I need to turn on the camera. So this is the command to activate the camera. So now camera is activated. Now the last step is to run the code, and this is my face detector code here. Wait, so let me run this. Wait. Okay, now I'm live through my PyCam here, so you can see it is showing me like, but it's not identifying me. The main problem is that the light problem. So let me add some more light here. So as you can see, a blue box start appearing as I bring light on my face. So see, so this is not a trained model here, this is just a detector. Let me show you the trained model also. So this is now my trained model. Wait. The only issue is the light, and as you can see, my name start appearing in the bottom left hand side of the box. So this is working properly, right? Okay, so the steps now we are left with is to connect it with a physical lock. So once it will done, my project is complete. So thank you so much for watching this video. I hope you enjoy this. Vande Mataram.